Yes, I am serious. Today I selected a vector chapter. It will be discussed with you. Yeah, in this, I and you will be discussing this lecture. Purpose can be anything. My purpose behind it can be anything. Your purpose to behind watching this would be something else. Purpose would be a lot of things. Right now, we will discuss it. Understanding is more important, as you know. So rather than reading, we will see that yes, use of this is something, where to use it, how to use it, why to use it, what to use it. Okay, all the questions will come, we will accept that question. So here I am starting it from vector. This is a mathematic tools for physics. You can understand it for mathematics or for physics. It's your choice. This is also a chapter of physics and this is also a chapter of mathematics. Now we have started. I hope all of you are ready. Look at over here. Vectors, this is okay. Control plus. Okay, this is enough. Let me set up this one by one. Every topics will be covered. Okay, this vector is chapter. This vector is a chapter. In this, whatever topics will come will be discussed with you. Nothing will be ignored. Remember, yeah, unnecessary part will be ignored. Okay, unnecessary part, but necessary part will be discussed. Okay, will be discussed. Understanding point we should have. We should have understanding point. With the first topic we are starting, first is physical quantity. Remember, vector is a quantity. Okay, whatever quantity you are taking, if that quantity has a magnitude plus a direction, then that quantity you will call that quantity as a vector, because vector is a quantity but it contains those quantities which you will have a magnitude as well as a direction. Magnitude is nothing but just it is a combination of units and number. First of all, number will come, then units. You know that what is unit. If you don't know, then I will tell you about units in separate lecture, which is the first chapter of the physics of 11th class. So in this, I'm not going into too much details. Whatever will be uh, basics, not into much details. Little bit basics I will tell you, but not into much details. Okay. So unit is nothing but just what are you measuring? Unit will tell you that yes, if you take kg, then here kg is telling that yes, you are measuring a mass of object. You are measuring a mass of object. So I understood that you are measuring a mass of object because of you used kg unit. That's why. Number can be anything, 10, 15, 100, any number. This combination of unit and number both will be definition of magnitude. Remember, okay. Direction is what? Upward, downward, this side, that side, forward, nextward, north, south, east, west. All these are direction. Okay, all these are direction. We say x axis, y axis, z axis. All this will be considered as a direction. If you are telling a quantity is providing, if a quantity is providing a magnitude as well as a direction, then that quantity is a factor quantity. But what about only a quantity is providing magnitude, only magnitude, not direction, then that type of a quantity will be known as a scalar quantity. We have two quantities right now. First, scalar. Second, types of a physical quantity I am talking about. So first is a scalar and second is a vector quantity. We have seen what is a scalar, what is a vector. So physical quantity is what? Those quantities which can measure. If you are able to measure any quantity, then that quantity will be definition of a physical quantity. For example, here a definition of a physical quantity: the quantities by mean of which we describe the laws of physical physics are called physical quantity. If you did not understand this sentence, don't worry. I am here. Rather than reading this sentence, if it is looking complex, then I have a definition for physical quantities that any quantity is measurable. You are taking a quantity. If that quantity can be measured, then that quantity is a physical quantity. That's it. This was the definition from my side in simple English. Now we have some examples of a physical quantity. First is length, second is a mass, time, force. All these are physical quantity. We can measure. Length is measured in meter, mass is measured in kg, time is measured in second, meter, hour, force is measured in Newton. So we can measure all this. That's fine. Physical quantities can be measured. Yeah, emotions, feelings, thinking, all this cannot be measured. These are just opposite of a physical quantity. So in anything which are not measurable will be unphysical quantity, right? So because they cannot be measured, these emotion feelings are not physical quantity because they cannot be measured. That's why. That's it. Next we have, I think, types of physical quantity. First, magnitude only. If a quantity is providing only one magnitude, then it will be known as a scalar. Here you can say magnitude only. Then it is known as a ratio. Example, refractive index. Only magnitude. Only magnitude. Now look at over here. Magnitude. Yeah, only magnitude. This was only number, brother. Only number. Refractive index. Magnitude and unit. Magnitude and unit. Then it will be known as a scalar. Example, mass, charge, current. All these are magnitude and unit. Magnitude, unit, and direction. All these three. Then it will be a scalar. Then it is known as vector. Vector, not as velocity is a vector because it provides a direction. That's why force will provide a direction. When you will apply force on an object, then here you will be showing that yes, in this direction you are applying force. Yeah, torque is also a vector quantity because of it provides a unit, magnitude as well as direction. That's why. What's the difference between a scalar and vector? Just direction. A scalar does not have a direction, but vector has a direction. Right? Both are quantity. If someone asks about your mass and your answer is 60 kg, then person is satisfied because he got the complete answer. If you say 60, then person will not be satisfied. Person will be confused that what is a 60? What is a 60? 60 can be anything. 60 is a just number, right now. So any person will not be able to interact with this number. Okay? When you will apply this kg, then yes, here someone, anybody will be at interact with this. Yes, you are telling your weight, which is a 60 kg. Next, here we have this in this, if someone asks about location of your school and you only tell the distance of a school from current location, then person will not be satisfied. He will ask about the direction also. Yes, yes. When you say yes, my school distance from here to my school is a 15 kilometer, then then and there are some some turns. In that case, that person will not be able to reach that at that position because of he will because he did not get exact location, just he got distance. Okay, distance. So that person wants to know what uh, where is the location of your school. In that case, you will say that yes, in this in just to go, then left side, then right side, that's it, then my school will come. So this is at that side, or this side direction here, it matters. It came direction because it is mattering, that's why. Clear? We are not applying unnecessary this direction, no. It is important to apply. Clear? What about 60 kg? If we apply here direction, then it will not make any kind of a sense. For example, 60 kg in a north direction. What is happening over here? Of course, it is not making sense. Rather than saying 16 kg in north, we will say 60 kg is my weight. 10 kilometer in the right side is a correct way to tell a location with a direction. So this first is what? First is a scalar and second is a vector, because in this you are getting direction, that's why. A block is kept on a platform and someone asks you to apply a force of 10 newton on the block. Okay, on the block you will ask the person that in which direction you have to apply the force. Yeah, what are you understanding? Here you are understanding, there is a box. Okay, there is a box, and someone, you are saying to someone that just apply 10 newton force on this box. Now that person will also ask to you that in which direction do you want to me to apply force on this box, in this direction, or in this direction, or in this direction, or in this direction. Okay, so all these four are direction. Apart from this four, there are more direction that I can tell you, but not right now. Okay, so here direction are mattering. Okay, you will see in this direction, in north direction. Here direction, to tell direction was compulsory. Then we will say yes, force is a vector quantity. There are more quantities that are vector. We understood it with an example, which was a real life example. Next we have force. Here force is a vector quantity because to completely define a force, information of magnitude and direction both will be requirement. That's why here wooden plank, and this length is L 50 centimeter. Length is 50 centimeter. In this to tell length of this wooden plank, we did not need to tell a direction. That's why this will be known as a scalar. But when we will say yes, this was on this was applied force this much, and then it moved in this direction. In that case, we are saying this 10 newton was applied in this direction. Clear? So here force is coming as a vector quantity. Now next we have length of the wooden. Length of the wooden is how much? It's not working. Yeah, it's working. Length of the wooden is a 15 centimeter, and direction is not requirement to specify the length. Hence, length is a scalar quantity. Clear? This was very easy example to understand it in better way. Next line is that a physical quantity is a vector. If it has a magnitude, it has a direction, it has a unit. It follows rules of a vector addition. These are conditions to say that yes, this is a quantity. These are conditions. So that quantity should have all these conditions. Current is a scalar quantity because of current has magnitude. That's why, as well as a direction. Oh, current is going in this direction or in this direction. But why are we saying that this is a scalar quantity? Let's see what is the reason. Current has a magnitude as well as a direction, but it does not follow laws of vector addition. Laws of vector addition. So vector addition is also important, is also necessary. We will see what is a vector addition. Next we have a vector change on changing its direction. Yeah, value of addition of vectors also change on changing direction. For example, we apply two forces. We are applying two forces. Yeah, it is telling you that when we will add two vectors, then it can also become again third vector or a scalar. If after adding two vectors is coming a scalar, then what will we say? Of course, we will say that this quantity is a scalar. Here we are taking two vectors, and after adding these two vectors, we are getting a scalar. It will happen sometimes, and it happens with some quantities. Clear? So here, for example, if we are going to apply two forces, okay, each of magnitude 10 in same direction. Here in this box, you can see uh, one person is applying 10 Newton force in this direction. Another person is also applying 10 Newton force in same direction. Now, how many numbers of newtons are being applied in same direction on this box? On this box, how much? You would say 20 Newton. Of course, if vectors are in same direction, okay, in that case, that box will this box will move. Of course it will move because of vectors are in same direction. That's why. Remember also, this vector will be represented by just by this arrow, and this side will be known as a tail, and this arrow will be known as a head. We will see it right now, don't worry. uh, Now here, this first vector, then second vector, we are adding both. We have right now two vectors, and after adding these two vectors, it is becoming what? It is becoming a vector quantity. Here we added two vectors, then it became vector again. Now what else? What if now if we apply two forces, each of magnitude 10 Newton, okay, two forces, but in opposite direction. Here both are in opposite. 10 Newton force is being applied in this direction and 10 Newton in this direction. What is happening over here? Here whenever opposite will come up, of course, meaning of this is that we need to subtract both. But when it will come when same direction will come, meaning of this is that we need to add all those vectors. So in this case, if we subtract this 10 newton from 10 newton, then what will happen? 0 will come. So it is telling you that uh, net force is 0. Net force. If net force is 0, of course nothing will happen. Neither it will move nor nothing will happen, because of all same amount of newtons are being applied in both direction, uh, in opposite direction. That's why. So here we are subtracting. After subtracting, what is happening? This is giving us 0. That's why this will be known as result change. Result change on changing the direction of vector. Yeah, it will change if we change the direction of a vector. Then force is a vector quantity. Next we have water is being filled in a bucket with the help of two pipes. A speed is 3 kg per second. Not this is not a speed. This is a mass. 4 kg per second. Our masses follow rates of water in pipes. Bucket is filled at rate. Bucket is filled at rate 7 kg per second. It means in 1 second 7 kg is passing from a pipe. This was the meaning. Here, this is 3 kg. 3 kg is going in this in 1 second. In 1 second. If it was like 3 liter per second and 4 liter per second, then it is volume follow rate of water in pipe bucket will be filled at 7 liter. Yeah. Yes, here we are adding 3 kg, 4 kg, and now in the bucket how much water will come? 7 kg per meter in 2 seconds. 7 kg water, 7 kg per second. Hence also bucket is a filled at 7 kg per second. No change in result. In above cases, on changing the direction of a flow, mass flow rate and volume flow rate are a scalar quantities. 4 kg in this direction, 3 kg in this direction, both are going in one glass. This was the example of a scalar quantity. Next we have current. 2 ampere in this direction, 3 ampere in this direction. Then from here it is going in this direction, which is a 5 ampere. Now look at over here. This is 2 ampere in this direction, 3 ampere in this direction. Both meet at this, and in this direction it is going how much? 5 ampere. But still we say that current is a scalar quantity because it does not follow rules of vector addition. That's why when we are observing that it is providing direction, but it is not following vector addition, rules of vector addition. Let's see. As there is no change in result, result is the same. What is happening? Result is the same. Here you can see what is happening. Result is same. 2 ampere, 3 ampere. It is giving you 5 ampere. Result is the same. There is no change in result, hence we will call it as a scalar quantity. Now let's take a ball and pipe setup as shown below. In this is the ground. We are considering this a square as a ground, and this is a pipe. This ball, there is a one ball. A length of the pipe is a 4 meter. This is known as a Cartesian plane. Here, what is x is a horizontal and y is a vertical. This is known as x-axis, and this part is known as y-axis. This is x-axis. Now, also your focus should be on this. Okay, on this I am talking about. If we throw a ball here from this side in this pipe, it will come in this. So what is happening over here? Ball is given a speed of 4 meter per second in x-axis direction. In means of 4 meter, it covered 4 meter distance within 1 second. Okay. Within 1 second. Here you can see 4 meter it covered, but within 1 second it covered. At initial time was 0 and final time was 1 second. Ball will come out of a pipe after 1 second. So t will come as a 1 second. Case 2. Ball is given a speed, okay, of this much. With this much speed, ball is going to move in x direction, and similarly pipe is given a speed of 3 meter per second in y direction, this direction. Ball will go in this direction and pipe will go in this direction. What will happen? This ball, direction of this ball will be here, and at the end it will fall from here, rather than from here it will fall from here. It is happening because of, as x-axis is increasing, at the same time y-axis is also increasing. This is what is happening over here. If we give a speed to a pipe in x-axis as well as in y-axis, then what will happen? Ball will also go in axis, but at the same it will go also in upward direction. Here you can see initial distance of this ball was over here and time is over here. With this much speed, this ball is going upward, and with this 4 meter per second, with this much speed, it is going in x-axis. But what is happening over here? If we release this ball, then it will not fall from here. Rather than falling from here, it will fall from this side. Height is here how much? 3 meter. 3 meter. And this is a hypotenuse. 4 meter is a base. 3 meter is a perpendicular. So this is a height. Okay. And vector is nothing but just this hypotenuse is a vector. Clear? So what did you understand from this figure? You understood that if x-axis is increasing and at the same y is also increasing, in that case that position of the point will be, it means if x is also being increased and y is also being increased, it means a point is increasing in x-axis as well as in y-axis. This is what is the meaning of this figure. Ball will again come out of a pipe after 1 second, but it took a height. But it took a height. It took height because it was also going upward. That's why. But this time at a different location, ball travels 5 meter in second. Velocity of a ball is 5 meter per second. Here ball has been given two velocities in x-axis as well as in y-axis. Two velocities of uh, velocities of 4 meter per second in an axis. This was one velocity, and second we have a velocity of 3 meter per second in y direction. These are two velocities that were given to a ball. Next we have vector addition of two velocities, 3 meter per second and 4 meter per second, gives a velocity of 5 meter per second. This vector of this and this is coming out as of 5 meter per second. If we add this 3 meter plus 4 meter, then it will become 7 meter. Rather than becoming 7 meter, it is becoming 5 meter per second uh, by the help of Pythagoras theorem. Here we will see some formulas of vector chapter. This ball was over here, then t was 0. When it came over here, then t became 1 second and it covered 4 meters per second. We know in case third, ball is given a velocity of a 5 a velocity of a 4 meter per second in x direction. Okay, ball is given a velocity of 4 meter per second in x direction, and similarly pipe is also given a velocity of 3 meter per second in x direction. Again in direction is the same. Now what will happen? Ball again comes out of pipe after 1 second. Pipe is also given a velocity of 3 meter per second in x direction. The time ball travels 7 meter. Now it is covering 7 meter and velocity of ball is 7 meter per second. It means in 1 second it covered 7 meter and direction was the same. Was the same. But this I think look at over here. Here resultant of two velocities 3 meter per second and 4 meter per second is coming out as a 7 meter per second. Result change on changing the direction of velocity. Velocity is a vector quantity. Okay. Okay. Definition of a vector is what? It is a physical quantity is said to be a vector in addition of magnitude and unit. It has a specified direction. Yes. It also obeys the parallelogram law of vector addition. We will see. This is a parallelogram addition. It means R is equal to in under root of a square plus b square plus 2ab cos theta. This is a formula of a parallelogram law of vector addition. We use this to add a vector. If we have two vectors, then okay. Next we have and its addition is a commutative addition. Here we are talking about addition, not multiplication. Vector of a plus vector of b will be equal to vector of b plus vector of a. Okay, this both will be valid in this case. Now next we have geometrical representation of a vector. In graph, how to represent any vector. Okay, what is the correct way? That is what we are going to see in this case. Let's see here. uh, First, length of arrow. What is the length of this arrow? It will matter. Magnitude of a vector quantity. Okay, direction of the arrow head gives. Look at over here. Just visualize it from here to till here. This is magnitude and this direction head. This arrow is providing direction. Okay, and this just from here to till here, this line segment is a magnitude. But when you apply this arrow, it is giving you direction. Remember one thing is that this tail, this side, this end side of the vector which does not have arrow will be tail, and arrow side will be known as head. These two things will matter in this our chapter. These two things. So arrow side will be known as head, and without arrow side will be known as a tail. You will see use of this, don't worry. So length of arrow, this length, except this arrow, magnitude of vector, then direction of arrow head will give you its a direction. For example, three person A, B, and C are running on road as assumed. Here there are three persons. But here you can easily observe that there are two persons who are running in a same direction. But third person is running in a opposite direction. So here you can say this third person is running in west direction and these two persons are running in north direction. This first A person is running with 10 meter per second in east direction, and this person is running in this 15 meter per second in east direction. That's why this 15 meter per second will not be known as a speed. Okay, it will be considered as a velocity because it is providing direction. That's why. Okay, that's why. And this third is going in this direction with the 5 meter per second velocity. So velocity of A, either you can write like that, velocity of A is equal to 10 meter per second. Velocity of A, we are saying, okay, this is velocity of towards it. Here we cannot write a speed of A because it is providing east direction. That's why velocity of B is this much 50 meter per second and it is going in east direction. Velocity of C is 5 meter per second and it is going in west direction. There are two persons who are going in east direction, but only one third person is going in west direction, just opposite. When we will add this, then it will give us 25, and when we will subtract this 5 from this 25, then it will give you 20 meter. Length of arrow represents the magnitude. Remember, okay, segment line of the arrow will represent the magnitude of vector, but just arrow of the line will be providing direction. If we apply like that, only like that, Here you can see these are two line segments without any arrow. That's why this will be known as magnitude. But if you apply this just by applying this arrow, it is telling that this is vector. It is providing direction. That is what you will understand by this symbols. Length of arrow represents the magnitude of a vector. Direction of an arrow represents the direction of a vector. We have understood. Next, let's see for example. For example, here look at over here. Have you tried? If not, then nice. For example, there are two persons A and B are applying force of this much 50 Newton, and second person is applying 100 Newton respectively on the block, on the box as shown. Here visualize this figure. There is one box. This person is applying a 50 Newton force in this direction, and this person is applying a 100 Newton force in that direction. Now tell me, in which direction this box will move? Of course, in this direction. In this direction, this box will go, because in this person is applying more force. That's why, and it is applying in this direction. That's why. So this will move with 50 Newton, not with 100 Newton, because this just opposite 50 Newton force is being applied. That's why it is applying in opposite direction. That's why this 50 Newton will be subtracted from this 100 Newton. So this box will move with 50 Newton. Okay. Here force applied by a force on a force by a person on a block is how much? 50 Newton. Force applied by B on block is 100. And this is also known as unbalanced force. If after adding, if two vectors are opposite, there are two persons who are applying force in opposite direction, and amount of each newtons are same. In that case, those object will not move because of because of balance force. Here amount of Newton in both sides are same. That's why. Now let's see types of vector weather. Yeah, meaning of vector is done. We have seen a lot of things in the discussion of vector. Now let's see types of vector. There are a lot of types of vector, but some vectors we will discuss so that we can have clarity about the types of vector. We are starting with the zero vector. Just have a look. Read all these types of vector. Let me drink. First is zero vector. From this word, you are observing that vector, a quantity which has a zero vector. I think no, it is not complete definition for this zero vector. Let's see. We have this much types of vector. First is the zero vector. Second is parallel vector. Third is anti-parallel, equal vector, opposite vector, unit vector, collinear, coplanar. All these are easy to understand it. Let's understand all these types of vector one by one. what is happening over here? Let's see this varies types in this example below. 4%, there are 4%, one one, this is second, this is third, this is fourth. This A person is applying 50 Newton in this direction, this B person is applying 50 Newton, but direction of A is a different from B. Both direction of this both are not same, okay, are not same. Same here. I think it will be applying like that. In this also you can see this person is applying 50 Newton and it is not applying 50 Newton, rather than 15 it is applying, he is applying 30 Newton. So of course in this side numbers of newtons are more than this side, so of course this box will move in this direction. First we have zero vector, equal vectors, brother. Zero vector, which means zero. Equal vectors, vector having same magnitude as well as the same direction. Yeah, we saw that if there are two persons who are applying same 20 Newton in one side, both are applying in same direction, not in opposite direction. In that case, what will happen? The object will move. So here what is happening? If direction is the same, here you can say direction is the same, and number of amount of both persons are same. If all these are same, everything is the same, will be equal vector. So vectors are having the same magnitude as well as the same direction. Here you can see this like that. Force are equal vectors, okay. Opposite vector means there are two vectors who are opposite, both are opposite. First is in this direction, second is in this direction. Now with the real examples we can understand it. There is a one box and in one side there is a one person and in another side there is another person, both are applying. But what is happening over here? In this direction this person is applying force with 60 newtons, but in this direction same 60 newtons. In that case what is happening? These are opposite vector, and here object will not move at all. Vectors having same magnitude. We saw that in this side this person is applying 16. In another side this second person is also applying same Newton, and direction is opposite but magnitude is the same. So this example is of opposite vectors. Clear? Directions are opposite but magnitude is the same. In that case object will not move at all because of a magnitude is the same. Magnitude will be different and direction will be opposite. In that case object will move at all, okay, will move at all. Next we have this are opposite vectors. Parallel vectors. Do you know what is a parallel vectors? Direction, like that direction. If direction of this is like that, then parallel of this would be just the same, not like that, okay. So one vector will be parallel to another. This first is a parallel to this. If one vector is like that, so second will be also like that, okay. This is parallel, this is also parallel. But what about this? If you take this and another is like that, in that case both are not parallel, because direction of this is different from this. That's why. Even you can see angle is changing. Angle should not change. Here you will have to take two vectors to define parallel vectors. Direction of one vector is a parallel if same direction. Direction would be same. Okay, remember direction would be same. Magnitude can be different. Can be different. Here you can see vector having a same direction, but magnitude can be different. In that case, all these are it is telling you that, hold on, uh, this is telling you that first vector is here this, and second is this. Now you can see easily length of this is less than this. Length of this is, let's say, 5 meter, and this is length of this is a 5 meter, and length of this is a 2 meter. In that case, you can see magnitude of this vector is a 2 meter, and magnitude of this vector is a 5 meter. Both are different, magnitudes are not same, but one thing is the same, is that a direction of this and this both are in same direction. If direction are in same, directions are same, directions of vectors are same, and magnitudes are different, so this is a type of a vector which is known as a parallel vectors. Clear? Parallel vectors. Next we have anti-parallel, just opposite. Direction will be, yeah, if we have this and one is like that, this is known as anti-parallel. Direction of this in this and direction of this in this, this is known. It means one will not be parallel to another. This is not. Now definition would be what? Directions are changing. Directions of two vectors are changing. Both are different, not same. Magnitude is also different. Here vectors having different magnitude, but they are in opposite direction. It is talking about in opposite direction, like that. Anti-parallel, not this. This is not a definition of a anti-parallel. Anti-parallel, which means directions of vectors are opposite, like that. Clear? Clear? Next we have collinear vectors. Collinear. What is the meaning of a collinear? Collinear, which means the two or more vectors. This first, then second, then third. All these three vectors are in same direction. In same direction will be known as collinear vectors. Here linear, which means in one line. Direction can be any. It can go either this side. So this second would be in this same direction. Third would be in same this direction. All direction of all the three sides, all the three vectors should be in same, and one by one. Not this should not be here upward. No, this will not be collinear. Clear? All the three sides should be in one by one, attached. Clear? So what is happening over here? Vectors along same line. Here vectors along same line. Yeah, in same line. All vectors. There are more than two vectors, and all these vectors are in same line. Will be known as collinear vectors. Here you can see this is an example of a collinear. What is happening over here? These are two vectors. These are two persons applying same, 15 plus 10 newton, 16, 100 newton. All these two forces are being applied in same direction. Yeah, it is done. Now next we have coplanar. Coplanar, not collinear. Coplanar, planner. This word, planner, plane. On this there are how much? This is plane. Let's say this is a plane. In this all the if you have two or more vectors, and position of all these vectors are on one plane. You can see this one, this is second, this is third, fourth. There are four vectors which are on one Cartesian plane. All these are number of vectors are on Cartesian plane. Then this will be considered as coplane. So here vectors on same plane. Okay, on same plane. These four vectors are coplane. Next we have unit vector, which means magnitude is 1, and it will tell you only direction, because here magnitude will always 1, will be always 1, because the reason is that only work of this unit vector is to tell direction. That's it. A vector with the magnitude of unity is called a unit vector. Okay, next, unit vector in direction of this A, vector of A is also this vector A. So unit vector of this unit vector in direction of this would be what? Just A cap. This A cap, it is telling that this is a unit vector. Cap just we will replace this arrow by this cap to represent unit vector. Now remember, always this A cap will be equal to a vector upon its magnitude. Clear? It can also be written as a vector, and this is equal to A. Because here we applied magnitude will remove this arrow. Always remember, whenever magnitude is coming after applying magnitude, that if a number has a negative sign, then that sign will be converted by magnitude into positive, and positive will be positive. Okay, positive number will not be converted into negative just by using magnitude. Only magnitude will convert a negative operator into positive operator, not a positive into a negative vector. Okay, this is the rule of magnitude. This part is done. Let's have an example to understand unit vector. Two persons A, B are running. Here you can see this person, both are running in one direction. Yeah, running along direction B with velocity of 10 meter per second and 6 meter per second. Maybe this person will be running with 10 meter per second, or this person will be running with 6 meter per second respectively. So first A is running with this much 10 meter per second, second is running 6 meter per second along in this. Both are running in same direction. Viewing from the top. Here what is happening over here? uh, this cap is equal to vector of a vector a upon magnitude of a vector a is equal to unit vector in p direction. Here it is a b. Yes, this is 6 p is equal to 6 upon t. This is 0.6. If you want to find a unit vector in any direction, unit vector along p, if you want to find a unit vector in any direction, then take a vector in that direction. Yes, divide the velocity, divide the vector by its magnitude, then you will get unit vector. To calculate unit vector is that just take a vector that is going in that direction, then divide that vector by just its magnitude, then you will get unit vector. We are left with only direction. Addition of vectors. Angle between two vectors. Here, if we bring this over here, vector b, let's say we brought this over here, then it is forming a angle. This is forming a angle between two vectors. It is talking about this, and another angle could be like that. If we draw this in this direction, but this is the opposite direction, not in same direction. We will talk about this later. So right now I can say that if we bring this secant vector over here with this here we are adding tail to tail of b vector with the tail of a vector we are adding. In that case it will form a angle, and this angle is, hold on, this angle is talking about this. We will get the angle by just two vectors when tail of a vector and tail of another vector will be added together. Then there will be chance to get angle between two vectors. We can shift a vector parallel to itself. Here direction will not change itself. Here we didn't change. We will not change the direction of this b vector. Direction will be same, but it can be shifted to get a angle. Okay, when we will shift it, then here we are adding tail to tail. To find the angle between two vectors, we have to place them tail to tail. Here, look at this word, tail to tail. So here this side is known as a tail, and this arrow will be known as a head. So here we are getting this because of here tail was added with this tail. Laws of vector addition. There are two laws of vector addition. First we have a triangle law, second we have parallelogram, third we will see later. So first triangle law, let's see. Given that angle between whenever you are understanding about a triangle, whenever you are taking triangle or parallelogram, then you should have two vectors. So right now you can see this b vector and this a vector. Given that angle between a vector and b vector is how much? This is a theta. Find this. We know that when we will add this vector and this vector, it will give us this c vector. But where is the c? In the First of all, we will have to add this, but remember direction should not change it's a cell. Then third, if we are adding this tail to tail, if we are adding tail to tail, in that case third C will start from origin, like that. Here we added a vector with its self tail with another tail of another vector. But what about if we add a tail to head, head to tail? In that case, you will not get like that vector which will not start from origin of the Cartesian plane. It is starting from origin because we added two vectors tail to tail. That's why. So here what is happening? This is first and this is second, and third will be this. Just we draw third vector is a C. Draw this first vector as it this first shift this second vector as it is and keep the tail of a second vector on the head of first vector. So here look at over here. In this case, second vector we are adding this we are adding part of this head, not head, tail, with the head of the first vector A. Okay, like that. But remember, direction should not change itself. In that case, we are getting this third. We will draw from tail to head, like that. So this remaining part will be known as C, third vector. We will get like that on graph. Join the tail of first vector with the head of a second vector, then it will give you sum of first vector plus the sum of vector second vector will give you a vector of a C. Next, let's say we have a equation vector A plus vector B. Find this. Direction of this is in this and direction of this is in this. Just we will bring this over here like that without changing direction of itself. Now we have shifted this without changing itself direction. Now third will come like that. So here you can see what is happening over here. Brother? Yeah, tail to tail. In this we are adding this tail to tail and here tail to head. This third is what vector C. Clear? That is how you will draw. This is law, which is known as a triangle law. Here it is becoming triangle, isn't it? That's why this law will be known as a triangle law, because it becomes a triangle. That's why it becomes a triangle. That's why. Here you can see what is happening over here. Next question we have, angle between this angle A and angle B is theta, and the magnitude of this is what, just A, and magnitude of B vector is B. Find this much. First of all, we will bring this over here. Second, third will be like that. What else? So this is A and this is B. So we know that vector C, magnitude of this would be nothing but just a C. So cos theta is equal to base upon hypotenuse. So in that case, we will take this theta, and here this theta cos we are taking cos theta. So cos theta is equal to nothing but just according to this theta, this is a perpendicular and it is a base. So base will be this A upon this is C vector. C, A upon C, X upon B. It is a new angle between two vectors, this much. This is question, we will see it later. Here what is happening over here? Magnitude of this A vector is 5 and magnitude of this vector is 10, and angle between these two vectors is given, which is a 16 degree. It is telling you that this is a B vector and this is a A vector, and angle of this two vectors is a 60. This is a 60. So magnitude of this A is a 5, measure of this is a 5, and measure of this is a 10. So what will be measure of this measure of this would you then find? We know that cos 60 would give us nothing but just 1 upon 2. Clear? And this is equal to 10 upon 5, not 10 upon 5, 5 upon 10. 5 upon 10. What is happening over here? 10 will go here, and 5 to the 10. 1 is coming. C as 1. C is coming as a 1. In details we will explore it, don't worry. It is just numericals. Here let's analyze the process of this. After adding this with its magnitude, this is 5 and B is this much, data is given. C will come as by using this like that, this formula. Here we are finding unit vector alone. In that case we will have to use this formula. Then A is this and B is this much, and cos theta 60 is 1 upon 2. After simplifying this we will get this much. Here you can see sum of these two vectors with with magnitude is equal to C, and this is equal to 175 in under root. Next, here you can see angle between this vector A and vector C. It is a tan lambda is equal to B sin theta upon A plus B cos theta. Just put B whatever is the value of B is, and sin theta is a 30. Sin 60 is a root 3 upon 2. As you know, A whatever is the value of A, just put this and value of this. Then simplify this. After simplifying this, you will get this much. Then at the end you will get root 3 upon 2. Here you can see lambda is equal to this much. This is your answer. I will tell you in details about it in separate lecture when I will be solving only question answers. Then at that time I will tell you meaning of answer, meaning of a process, reasons will be explained with you. Here just I can analyze that, yes it can like that, that's it. Okay, in this lecture my focus is on concept, just to understand it as in better way, as much as I can understand this concept in too much better. Okay, next question we have here. You can see this magnitude of a vector is 4. It means measure of A is 4 and measure of B is 3, and sum of these two vectors with magnitude is 5. With magnitude is 5. So sum of this is this one. The angle between this will be how much? Same formula we will use, this formula. When we will use this formula, then we will get this cos theta is equal to something. So cos theta is 0. It means this is cos I think 90 is equal to 0. So theta is coming as a 90. So just in this question, just we applied this formula, and we know that a is a given, b is a given, a is a given, b is a given, and this sum of two vectors with a unit with magnitude is equal to c. We already know this. So just we applied this formula, then we substituted something, and then at the end we got this much angle. Now next we have angle between these two vectors is not with magnitude. Okay, angle between these two vectors is this much. Magnitude of this a is a, magnitude of this b vector is a, both are same now. And find sum of these two vectors with the magnitude and angle between this c vector and a vector. So question is that between this angle lambda we will have to find with the help of this c. We will a is a, okay, theta is given, this theta is given. This is a big process, we will analyze it later. Parallelogram is what? Parallelogram, I told you that just we will shift this over here without changing its a direction, and here we added this tail to tail. In that case, the third vector will come from the origin. So parallelogram will give you a third vector which will start covering a distance from the origin. So this is known as a parallelogram. It means this is parallel to this is parallel to this. It is not completely parallel to each other, to other vectors I can understand, but yes, it is looking like it's a parallel. That's why we are calling it as a parallelogram. So angle between vector A and vector B is a theta. This between this is a theta. As per parallelogram, draw two vectors such that their tails coincide. This imaginary part, this is a C, this is a C, clear? We are imagining this. It is becoming parallelogram like that. It is not becoming triangle, clear? This is a diagonal. This is a diagonal. So formula for this is this. This is not for this. What else do we need to understand? Polygon law we will see, don't worry. In the case of polygon law, we can add two or more vectors. Okay, we will explore it later. All this will be covered in this. All this is enough. Whatever is coming will be covered in another lecture. Components, all this will be covered in next.